Hello students, today's topic is topological sorting using source removal method. Topological sorting of a graph is the linear ordering of its vertices. It is important to note that topological sorting is possible only if the graph is a directed acyclic graph. Directed acyclic graph means the graph adjusts with direction and there must be no cycle. There may exist multiple different topological orderings for a given directed acyclic graph. Topological sorting methods. First one is source removal method. Second one is depth first search. Below are the steps for finding topological ordering using source removal method. Step 1. Calculate in degree of each vertex. Step 2. Select a 0 in degree vertex. Step 3. Remove that vertex and its associate edges. Add removed vertex into cube. Step 4. Update the in degree of other vertices. Step 5. Go back to step 2 until all the vertices are added into cube. Okay, these are all the 5 steps we have to apply on the given graph to find the topological ordering using source removal method. Problem 1. Find the topological ordering for the given graph. The given graph consists of 5 vertices A, B, C, D, E. Step 1. Calculate in degree of each vertex. In degree means the incoming edges to the vertices. Out degree means outgoing edges up from the vertex. For the vertex A, there is no incoming edges, so the in degree of vertex A is 0. For the vertex B, there is one incoming edge, that is from A to B, so the in degree of vertex B is 1. For vertex C, there are two incoming edges, that is from A to C and B to C, therefore in degree of vertex C is 2. For the vertex D, there are two edges coming from one from vertex A and one from vertex B, so the in degree of vertex D is 2. For the vertex E, there are two edges are coming from C and D, so the in degree of vertex E is 2. Next, step 2. Select a 0 in degree vertex. Okay, in the given graph, there are 5 vertices are there. In that 0 in degree vertex is vertex A. Vertex A as the 0 in degree. Step 3. Remove vertex A and its associated edges. Okay, in that given graph, I am removing the vertex A and its associated edges. Okay, this is a graph after removing the vertex A and its edges. Add vertex A into cube. I am adding the vertex A into cube. Step 4. Update the in degree of other vertices. Now we have to update the in degree of the other vertices. For the vertex B, there is no incoming edge, so it is 0. Vertex C, there is one incoming edge, that is from B to C, 1. Vertex D, there is one incoming edge, that is from B to D, 1. E, there are two incoming edges, so the in degree of E is 2. Step 5. Go back to step 2 until all the vertices are added into the queue. Right now only one vertex A is added into the queue, so I am going back to the step 2. Select a 0 in degree vertex. Vertex B as the 0 in degree. Step 3. Remove vertex B and its associated edges. Add vertex B into cube. Update the in degree of other vertices. Okay, now for the vertex C, there is no incoming edge, so the in degree is 0. For the vertex D, there is no incoming edge, so the vertex D in degree is 0. For the vertex E, there are 2 incoming edges, so the in degree of vertex E is 2. Go back to step 2 until all the vertices are added into the queue. Okay, right now only 2 vertices are added into the queue, so I am going back to the step 2. Select a 0 in degree vertex. Now vertices C and D as 0 in degree. In this case, select any vertex of your choice. Here I am selecting vertex C. Step 3. Remove vertex C and its associated edges. Add vertex C into Q. Update the in degree of other vertices. Now for the vertex D, there is no incoming edges, so in degree of vertex D is 0, and there is only one edge coming to the E, so the in degree of vertex E is 1. Step 5. Go back to step 2 until all the vertices are added into the queue. Right now only 3 vertices are added into the queue out of 5 vertices. Select a 0 in degree vertex. Vertex D as 0 in degree. Step 3. Remove vertex D and its associated edges. Add vertex D into Q. Update the in degree of other vertices. Now the remaining vertex is only E. It not having any incoming edges, so the in degree of vertex E is 0. Go back to step 2 until all the vertices are added into the queue. Right now 4 vertices are added into the queue, so I am going back to the step 2. Step 2. Select a 0 in degree vertex. Vertex E as 0 in degree. Step 3. Remove vertex E and its associated edges. I am removing the vertex E. Add vertex E into Q. Vertex E is added into the Q. Update the in degree of other vertices. Okay, there are no more vertices in the graph. Go back to step 2 until all the vertices are added into the queue. Okay, now all the vertices are added into the queue, so it terminates the algorithm. Final result is topological sequence of the given graph is A, B, C, D, E. Okay, now we have to remove the one by one elements from the queue. So the sequence of ordering of vertices is A, B, C, D, E. Overview of the problem. In the problem, first they will give the graph. For the graph, first you have to calculate the in degree as shown in the figure 2. Now from the figure 2, you have to select the 0 in degree vertex. So 0 in degree vertex is vertex A. I am selecting that one and I am removing that vertex from the graph and its associated edges and adding the vertex A into the queue. Now the figure 3, that is the resultant after removing the vertex A and its associated edges. Next, calculate the in degree of the graph as shown in the figure 3. Okay, the in degree of B is 0, C is 1, D is 1 and E is 2. Okay, next you have to select the vertex with in degree 0. Now the vertex B, it has in degree 0. I am selecting the vertex B and deleting that vertex and adding that vertex B into Q. Okay, after removing the vertex B and its associated edges, the resultant graph as shown in the figure 5. Next, for the figure 5, you have to calculate the in degree. In degree of C is 0, D is 0, E is 2 as shown in the figure 6. Okay, next you have to select the any vertex with in degree 0. Now the vertex C and D, they both have the in degree value 0. In that case, you have to select any vertex of your choice, and here I am selecting the vertex C. So I am removing that vertex C and its associated edges and I am adding that vertex C into Q. Next, in the figure 7, that is after removing the vertex C and its associated edges. Okay, next calculate the in degree of the graph shown in the figure 7. D value is 0, E value 1. Next I am selecting the vertex with in degree 0. Now the vertex D in degree is 0, I am selecting that vertex and I am removing that vertex from the graph and adding that vertex into Q. Last vertex is E and there is no incoming edges, so the in degree of vertex E is 0. Next I am deleting that vertex and adding that to the Q. So the topological sequence is you have to remove the vertex one by one from the Q. The topological sequence is A, B, C, D, E. Okay, I hope everyone you understand the problem how to find the topological ordering by applying source removal method. Practice question 1. Find the topological ordering for the given graph. Students, solve this one and submit your answer in Google Classroom. Practice question 2. Find the topological ordering for the given graph. Okay, this graph it consists of 8 vertices and you have to find the topological ordering for that one. Solve this problem and submit your answer in Google Classroom. Practice question 3. Find the topological ordering for the given graph. Okay, everyone you have to solve this one and submit your answer in Google Classroom. Thank you.